Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe.
Level 163, the angle 80 by 60 by 10 mm structural angle has the following cross-sectional properties. I sub x is 0.808 times 10 to the 6 mm to the fourth, Iy 0.388 times 10 to the 6 mm to the fourth. And I sub 2, one of the principal moments of inertia is 0.213 times 10 to the 6 mm to the fourth, where I2 is a centroidal principal moment of inertia. Assuming that the product of inertia x sub y is negative, compute I1, the other principal moment of inertia, and the principal directions at the centroid. There is the given figure, and there's nothing to worry about the location of the centroid. It is indicated here, and the centroidal moments of inertia Ix and Iy are given also. So for the solution, let's plot Ix, which is 0.808 comma negative pxy, because pxy is to be assumed negative here, and the other part is 0.388 times 10 to the 6, but we'll just use 0.388 comma positive pxy. So assuming that each graduation is zero point 0.1 times 10 to the 6, so 0.808 would be somewhere here, and pxy is assumed to be negative. No specific value for pxy as long as it is negative. So this is the first point. There lies the centroidal x-axis. And the other point is 0.388 comma positive pxy. So connecting these 2 points, that's the diameter of the Mohr circle. The first point plotted is the x sub c axis, and the second point is the y sub c axis. They are separated 180 degrees apart in the Mohr circle, 90 degrees apart in the actual figure. So this is x sub c, and the other point y sub c. So the center, which is the average of Ix and Iy, I bar x, I bar y, 0.828 plus 0.388 divided by 2 is here. So it is 0.598. Then we can have I2, which is 0.213 here, the minimum value. So this is I1, the maximum value. And the radius of the Mohr circle is denoted by R. Then R, R, this is I sub 2. So from the figure, I sub 2 plus the diameter 2R equals I1. So I sub 2 plus R equals I sub C, which is 0.598 from the figure. So I sub 2, this is I sub 2, plus radius equals the coordinate at the center, which is 0.598. So solving for R, where I2 is 0.388, 0.213 rather, given here, 0.213 times 10 to the 6, plus R equals 0.598. So that means R is equal to 0.385 times 10 to the 6 mm to the fourth. So from the figure, I1 is equal to I2, 0.213 times 10 to the 6 plus 2R to get I1. So computing for I1, I1 is equal to 0.983 times 10 to the 6 mm to the 6 mm to the fourth. So this is the principal direction to theta 1, and cosine of 2 theta 1 equals 0.808 minus 0.598 at the center divided by r. So cosine of 2 theta 1 equals 0.828 minus 0.598 divided by r. From there, we can solve for theta 1. It is equal to 28.47 degrees. Since the principal axes are separated 90 degrees apart, so if theta 1 is for 28.47, the other principal axis for theta 2 is theta 1 plus 90 degrees. Remember, the principal axis 1 and 2 are separated 180 degrees in the Mohr circle. Here, in the actual figure, they are separated 90 degrees apart. So to get theta 2, we just add 90 degrees from theta 1. So theta 2 is equal to 118.47 degrees. So that's it for this problem. Level 164, determine I sub u, I sub v, and the product of inertia P sub uv for the rectangle where C is the centroid of the area. So here's the given figure. Take note that it is a rectangle, although it is inclined with respect to the xy axis, which are the axes of symmetry. Then we can compute Ix and Iy. These are centroidal axes, x and y. So Ix or I bar x is equal to base 18, height 12 cube over 12. So bh cube over 12. So that case 18 12 cube over 12. So 18 times 12 cube over 12 is equal to 2,592 inches to the fourth. I sub y, on the other hand, or I bar y, is equal to 18 cube times 12 over 12. And 18 cube times 12 over 12 is 18 cube, and it is equal to 5,832 inches to the fourth. Because the area is rectangular and both axes are axes of symmetry, the product of inertia with respect to the centroid C, Pxy or P bar xy is 0. So take note from the centroidal x-axis, we can locate the u-axis, centroidal u-axis by rotating clockwise through an angle theta, but in the Mohr circle 2 times theta, where from the figure tangent of theta is equal to opposite, which is half of 12, so 6 inches divided by half of 18, 9 inches. So this is the figure. Ix is plotted. It is on the principal axis. These are principal axis of inertia, Ix and Iy. So we have 2592 for Ix. We assume that each grid is 500. So 2592, 500 inches to the fourth. And the other one is 5,832. So I'll just approximate it. So that's it. Then we draw a circle and we locate the center, which is the average of 2592 and 5832. So this is the first point plotted, so that's the x sub c, and this is the second point plotted, y sub c. And the center is at 2592 plus 5832 divided by 2. So that is equal to 4212. The radius therefore is 4212 minus 2592, or 5832 minus 4212. So tangent theta is 6 over 9. So take note that to locate the u-axis, we rotate from the x sub c axis clockwise times 2 of this angle. So theta is 33.69 degrees. And since this is the x-axis, we rotate clockwise 2 times 33.69. So we can locate the u-axis, centroidal u-axis, which is here. And this is the opposite centroidal v-axis. And the angle is clockwise from this x sub c axis, yellow one, 2 times 33.69, and that is 67.38 degrees as shown. So this is I sub u, or centroidal I sub u. This is centroidal I sub v from here to the principal product of inertia axis shown. And PUV is positive because it is above the principal axis. So since we have a right triangle with radius r, hypotenuse, and projection here is r cosine of 67.38 going to the left, so we just minus, subtract from 4212 from the center. So that's r, 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 the radius of the Mohr circle. So from the figure, I sub u is I sub c, which is 4212 minus this horizontal projection, r cosine 67.38. So r is 4212 minus 2592. So the radius is equal to 1620 inches to the fourth. I sub u therefore is equal to center 4212 minus r cosine of 67.38 degrees. From there we can solve I sub u. It is equal to 3589 inches to the fourth, while I sub v is 4212 plus, so we just add plus r cosine 67.38. So 4212 plus 1620 cosine 67.38 degrees. So I sub v is equal to 4835 inches to the fourth. Finally, PUV is r sine 67.38 from this triangle, right triangle. So PUV is r sine 67.38, and it is equal to 1495 inches to the fourth. So that's it for this video. I hope that you are able to follow the solution and the explanations.